Critical Thinking Rule 16, Cross-Check Sources. Previously, we've discussed the importance of having informed and impartial sources. An informed source is one that has lots of information. An impartial source is one that's not biased. It uses its information rationally to reach beliefs. Independence is a third different type of criterion. It's not the same as being impartial. Independent means that multiple sources have gotten their information and analysis separately. So unlike the criteria of being informed and impartial, which can apply to an individual source, independence only applies to multiple sources. It's when you have multiple different sources that aren't just copying each other, that have their own lines of information and analysis. This is good because if multiple sources report the same information, it increases our confidence that the information is accurate. Rule 16 says to cross-check sources, which means to seek multiple independent sources. So we're asking, are there other informed, impartial sources out there, and do they agree? Make sure that the sources are truly independent. That is, it's not just a bunch of sources copying one original source. This often happens with news stories. If there's a new study, for example, about the health effects of eating red meat, that one study could be reported on by many different news outlets. However, if you have an article by different news outlets, for example, CNN, Fox, CNNBC, Vox, whatever, then those do not count as multiple independent sources because all of them got their information from the same place, the same scientific study. Seeking independent sources relates to the concept of data triangulation, which is looking at the same problem or question from multiple perspectives or points of view. So for example, using different methods in order to analyze the same topic, or literally just different sources with different points of view. So triangulation implies 3 points of view, but it's 2 or more, really. 2 or more independent points of view. If they arrive at the same conclusion, then that increases your confidence the conclusion is true. You can also ask about the distribution of sources that agree or disagree with the claim. In cases where you have multiple independent sources, but they don't agree, you don't have to just stop there and say, well, there's no consensus. Sometimes there can be a consensus in terms of the majority of sources agreeing. For example, if you have 70, 80, or 90% of sources agreeing on an issue, that should increase your confidence that their claim is true, even if there are still some other sources that disagree. Ideally, you want to find a representative sample of sources. For instance, if you're trying to look at what the science says about the health effects of eating red meat, there's probably hundreds of studies that have been done on this. So if you only focus on ones that say there's no negative health effects of eating red meat, or you only focus on ones that say there are negative health effects, that's going to bias or distort your judgment. Because there's likely some disagreement in the scientific literature, try to find a sample of sources that's representative. Ideally, if you had the time and resources, you could track down every piece of research that's done over a given time period, say the last 10 years. But if that's not possible, you try to go for what seems like a representative sample to get a sense of the distribution of views. Finally, another special case is if you have multiple sources that are not impartial. This can still be helpful for purposes of Rule 16. If you have multiple sources that are biased, but they have opposing biases. For example, if you wanted to read the news about some international political event or some event from domestic politics, and you had sources, some of which were leaning to the right ideologically, others were leaning to the left ideologically, or different types of biases, then if they still agree on a claim, that increases your confidence in the claim even more. So paradoxically, biased sources can be okay and even a good thing if they still agree despite the bias. That means that there must be really strong evidence for a claim if the biases didn't affect it. It's important to distinguish a meta-analysis from a single scientific study. A meta-analysis is a systematic evaluation and review of previous research on a given issue. The picture on the right is an infographic display that was presented in one meta-analysis study, and it kind of summarizes the different quality and quantity of research on a particular issue relating to the brain. Another example of a meta-analysis could be if you were interested in this question of what are the health effects of eating red meat. You could look at all of the scientific research that's been published on this question within a given time frame, such as the last 10 years. That would be a meta-analysis. One meta-analysis contains many independent sources. Most or all of the scientific studies that are reviewed in the meta-analysis are going to be the result of different scientists or different teams of scientists, each using different methodologies and perhaps each with its own biases. So one meta-analysis counts as following this rule of seeking out multiple independent sources. You should also be aware of the difference between looking at one database versus one study. If a meta-analysis or some other publication references all of the research in one database, that is much more powerful than only referencing a single scientific study. So a database includes all or much of the scientific research on a given topic. And a database will typically try to be as broad as possible, so it will try to include as many different scientific journals as it can. So it may not include, strictly speaking, all of the research that has been published within a given scientific field or fields, but it generally is a very wide proportion of such research. So if you do a search on a database and see what you turn up for a kind of informal meta-analysis, this is also much more powerful than just looking at one scientific study, which could have a flawed methodology or a bias or some other problem. There are also cases, however, in which there's only one source of information. An example might be if you're trying to answer the question, how many people of Chinese ethnicity live in Canada? With this type of highly specific question, it's possible that a single source like Statistics Canada, which is the Canadian government's census website, may be the only independent source. So in some cases, an inability to follow this rule of seeking independent sources will not be a fatal flaw for an argument if there's only one source that can be obtained in the first place. Next up is Rule 17, build your internet savvy. It's how to be careful in finding good sources on the internet.